Okay, welcome back to our second video lecture for Chapter 2. So today we are going to be covering, since we've now discussed some of the key criteria for good research and what might make research not so great, now we're going to talk about the types of research that we can do. So we're going to basically start out pretty broad and talk about the major areas of research, and then we're going to delve a little bit more into a lot of the different terms associated with each. So we'll talk about descriptive studies, we'll talk about correlational studies, and we'll talk about the experiment, which is kind of the big one, the one with all the different variables and different groups and why random assignment and things like that are so important. This is actually one of my favorite topics. I'm kind of a data nerd or a stats nerd, so hopefully you enjoy it. But if you do have any questions about research methods, feel free to reach out to me, because I know it isn't exactly an easy topic for students to kind of grasp the first time around. I do, however, have a review that I actually did up a couple of years ago, and it's basically a full PowerPoint that takes you step by step through a research scenario and how you can examine it using all these different types of research. So I'll definitely have that up for you as well before the exam, so that you can kind of follow through it and hopefully gain kind of a greater understanding as to how we might conduct some of these types of research. So, Module 2.2 is Scientific Research Design. There are many different types of research designs. A research design is basically defined as a set of methods that allow a hypothesis to be tested. And so a psychological scientist may engage in any number of different methods when conducting research. However, there are both kind of benefits and limitations to each type, so it's really important that we learn about each of them and how they may best be used. No matter what design you choose, they all have at least three things in common. There's always going to be variables, which are the things we're trying to measure, as we discussed in the last lecture. There's always going to be the need for operational definitions, which again, as we discussed last lecture, is defining the term in the way that you are going to measure it within the context of your research. And we're always going to have some type of data. There are a couple different types of data, we'll get into that in a second, but you are going to be collecting some kind of data that you can then kind of further analyze and draw your findings and conclusions from. So the three main types of research we're going to focus on are our descriptive research, our correlational research, and our experimental research. So descriptive methods allow researchers to predict and describe behavior, but they do not necessarily help choose one explanation over others. This is something that's very important to keep in mind. When we are talking about various types of research methods, there is only one type of research that can actually allow us to draw conclusions about cause and effect relationships, and that is an experiment. So descriptive research will allow us to look at behavior, describe it, and maybe even help us predict it, but we're not actually going to be able to kind of say anything about cause and effect relationships. So descriptive research is often used as kind of the first step in a program of research, and it can be used to help inform more sophisticated future studies. So these descriptions can be performed in different ways. So the two major ways and major kind of subsequently types of data that you'll collect are qualitative research and quantitative research. Qualitative involves examining an issue or behavior without performing numerical measurements. So qualitative research might be sitting someone down and conducting an interview, like kind of a spoken and oral interview, where you just ask them open-ended questions and they provide you with answers. So it's not something that we can actually kind of quantify numerically. We can't put a number on their answers. Whereas on the opposite side of that, quantitative research involves examining an issue or behavior by using numerical measures and or statistics. So if I was going to ask you to rate something, tell me how you feel about this on a scale of 1 to 7, then you are going to be providing me with a number, which I can then, if I've got a bunch of different participants, I can then take the average of those numbers and kind of look at the data kind of all aggregated together, whereas in qualitative research, it's kind of more individual. Each person is going to have different answers. You can't really kind of put a number to them or quantify them in that way. So some examples of descriptive research include case studies. naturalistic observation, and surveys and questionnaires. So we're going to talk a little bit about each of those in the following slides. So a case study is very commonly used in areas like psychology, also in medicine, because it is an in-depth report about the details of a specific case. So again, it's most commonly used by clinicians. It sometimes appears in academia as well, so kind of research in an academic setting. But basically what a case study is taking one individual that differs from the population in whatever way. Maybe they've been the victim of a horrific accident that's damaged, a certain part of their body or a certain part of their brain, and we want to see if we can examine what the effects of that injury were. Obviously, we can't just take people and damage their brain to find out what happens. So in that case, we're going to take it as it comes and treat that person as a case study them in detail, and see what we can find. So some examples include Jeannie, which is a very sad story about a 13-year-old girl who was locked away basically in a room for her entire life up until the age of 13. She wasn't spoken to. She was basically just given the bare minimum of food and no really interaction with others. And when she was finally rescued at the age of 13, they found that she had no language ability. She was unable to talk. And by studying her, they determined that although they were able to teach her, the basics of the English language, she was never really able to grasp kind of the intricate details, like some of the grammar rules and more complex things that a native speaker would kind of do almost automatically. And so what that told us was that potentially there was a period within childhood that was really important for the development of language. So even though it was just one case and we couldn't really take that and generalize it to the overall population, that case kind of set the ball rolling in terms of the study of language acquisition and if there is kind of a critical period for language development. Another really famous example, and I think I mentioned him in chapter 1, is Phineas Gage. He was the railway worker who had an iron rod blasted right through basically his eye socket, right up through his brain. The rod was found quite a distance away, so it made kind of a clean cut. And he survived miraculously. This was years and years ago, but his personality was fundamentally altered. So he was much more impulsive and quick to anger. And so again, based on where the injury had occurred and the symptoms that he was showing afterwards, we were able to determine that, hey, maybe that area of the brain has something to do with those aspects of personality and kind of irrational behavior and risk-taking and things like that. So case studies such as those can be used to illustrate psychological principles in a way that would not be possible through statistics and generalizations. We can't just go around locking people up in a room or, punching holes in their brains to kind of see what happens. So a case study in those examples is the best way for us to kind of examine that case and see if we can learn anything from it. However, they are obviously not without their drawbacks. One might be missing or hard to interpret information. So because it is an in-depth study on one person, and you've probably got a clinician working very closely with them, it might be kind of hard to interpret the results that you are getting, the information you're obtaining. They can definitely be influenced by biases based on who the researchers are and what types of questions they're asking. The subject may have missing or inaccurate memories. Or, and this is a really big one, they may be unrepresentative of the group. Because again, remember, good scientific research is generalizable. But if you're just looking at a sample size of one, how is it possible for us to know if the results you're seeing there would generalize to the greater population? So your textbook examines case studies using that scientific literacy model if you want to take a look, just to get a kind of a better understanding. But for the purposes of our course, if you can kind of understand the definition, maybe know a few of those major examples, and then for all of these research methods, I would like you to be able to list at least one kind of positive or benefit of the research and one major limitation of the research method, because they will all have both benefits and limitations. And there's the the picture of Phineas Gage, and you can see this is actually the tamping iron that nearly killed him. So he's proudly kind of holding it. He's one of the most famous names in the history of psychology, just because, again, he was one of those first examples that really started getting us thinking about the localization of function in the brain and kind of what particular brain areas did. So this is the man himself in a portrait from way back then. Another type of descriptive research is naturalistic observation. There are two different types of observation, and for some reason this textbook only really focuses on naturalistic. But naturalistic observation is basically observation in the natural environment, whereas we have laboratory observation, which would be observing people within a laboratory context. So for the purposes of this course, since this is the one that's discussed in this textbook, we'll focus mostly on the naturalistic observation. But basically all it is unobtrusively, so you're not actually going in and kicking up a fuss and making them really aware of your presence. You're observing and systematically recording behavior as it occurs within the subject's natural environment. So these studies usually involve many participants. It's really easy to go into a mall food court or a bar or a movie theater and observe the actions and behaviors of the people around you. They're often the first step in a program of research. Just because if you think that there might be a connection with something, maybe the first thing you want to do is go out and observe people and see if that thought that you've had even has any basis in reality. I mean, if you don't see any evidence of what it was you were thinking of studying, there's not much point in continuing on with that line of study. So it provides a good description of behavior before we then maybe attempt to kind of delve a little deeper and try to explain it. It's very important in the case of any observational research that researchers must count, rate, and measure behavior in a systematic way to ensure they do not notice only what they expect or want to see. So you can't just go out to a bar or go out to a food court and watch people and kind of look at what they're doing and then go home and kind of write up some notes afterwards. You have to be observing them in a way that's systematic. You know, you're checking the box every time they do a certain thing, so that you are observing everything that's going on and you don't have that bias where you're kind of only looking for the things that you hope to see. You also must avoid being obvious about your observation so that people will behave naturally. So unfortunately, even though one of the benefits of naturalistic observation is that you observe people acting naturally the way they would normally, that leads to the major limitation of this research in that you don't have any control over the study setting. So one of the major examples that we talk about, this is actual social psychological research, which is my former field of study. They have had social psychologists go out and sit in a bar and watch people who are there alone versus in a group. And they wanted to see, to basically try to determine whether or not people drinking alone would drink more or less than the people who are drinking with a group. A lot of people would think, well, probably if you're out with a group of friends, you're more likely to have a few more drinks because you're socializing, you're talking, and you might stay a little longer. And so basically they just wanted to go out and observe this and see if that was correct. So unfortunately, even though it's great if you're just sitting there in the corner, nobody really knows what you're doing, they're not self-conscious about it, those people could get up and walk out of the bar and you have no idea what they're going to do. Maybe that group was actually going to stick together and go to another bar and have 5 more drinks, but you can't just get up and follow them because you are kind of in your zone and collecting your data. So you have very little control over what your participants are doing. Another example is watching hockey spectators. So there's been research where people go to, like minor league hockey games and they watch the behavior of the different spectators, whether they're cheering on the players, whether they're arguing with the refs or yelling at the refs or the players, and kind of trying to determine, whether males or females make certain types of comments more often. Your textbook kind of goes a bit more into detail about it, but basically anytime you're observing the natural behavior of someone in their natural environment without them really knowing you're there, that would be an example of naturalistic observation. Just as an aside, because again it's not in this textbook, laboratory observation eliminates the problem with control of the study setting, because then of course in a laboratory setting you have a lot of control, but it brings into question whether the person is actually behaving naturally. Because if they know they're being observed and you're monitoring their drinking, what do you think people are going to do? They're probably not going to maybe drink as much as they would normally because they might be feeling self-conscious about it. So you can see that with naturalistic and laboratory observation, the pro of one is kind of the con of the other and vice versa. Finally, with respect to our descriptive methods that we're going to discuss in this course, we have surveys and questionnaires. So both surveys and questionnaires involve the descriptive method of self-reporting. That basically just means responses are being provided directly by the people who are being studied. A self-report means that you're sitting down, you're filling out the survey or the questionnaire, and you're providing that information directly to the researcher. So some examples include interviews, surveys, paper and pencil tests, and questionnaires. These methods are really good at collecting a lot of data fast, especially if you're using technology to aid you. Obviously, if you have a survey and you've, say, done it up through SurveyMonkey online, you can send that link out to thousands of people at once. You know, if I wanted to send that link out to every single person at Brandon University, I could. So it's really easy to get a lot of data back in those cases, but we have to keep in mind they're difficult to do well. There may be issues with sampling, so maybe you have certain types of people who are more likely to respond than others. You may have biased questions, and it's really hard, especially if it's kind of using technology, to know if the participants are even understanding what you're asking them. You're not there for them to kind of ask about interpretations of questions and things like that. So there's a lot of kind of even further issues that using technology can kind of add to the self-report methods of research. So another issue is that people may lie, especially when they're asked about sensitive topics. So I kind of mentioned this back in the last lecture when we were talking about, the characteristics of quality research. If you're asking people about things like drug use, sexual history, sometimes they'll lie because they're embarrassed or they want to kind of make themselves look good to you. Of course, if we guarantee them anonymity, if we say, you know what, like, your results are going to be anonymous, we won't let anyone else see them, they won't know that they're yours, that can help alleviate the issue, but might not fully solve it in some cases. It's also very important to carefully consider which questions to ask and how to phrase them. A really kind of common technique used in creating surveys is known as counterbalancing. So you ask one question in a positive light, and then you ask one question in kind of the negative light. So what I mean by that is you might ask one person, rate on a scale of 1 to 10, how much you enjoy this course. And then the next question might be rate on a scale of 1 to 10, how much you dislike the content from a particular lecture. So they'll put one in terms of liking and the other one in terms of disliking. So that way, if a participant is basically just going down and picking the same answer over and over again, you can kind of very clearly see that they probably weren't really reading the questions. Because if they were answering truthfully, they really should have some that are high, some that are low in order to be consistent. Then we have correlational research. So we're done with our descriptive methods now. As you can see, there's a lot of different types. There are kind of pros and cons to each. So we'll move on to the second type of research we're going to talk about, which is correlational studies. Correlational research is technically defined as a method of inquiry which examines and measures the degree of association between two variables. So you take one variable that you're measuring and you take another variable that you're measuring, and you want to see if they're related to each other, if they have an association. So correlation is often used as a synonym for relation. People say if something's correlated, then it's related. But technically, the word correlation refers to a numerical measure of the strength of relation between the two things. So yes, there is a relationship there, but the correlation is going to tell us how strong that relationship is. So the two main characteristics of correlations are the direction. If a correlation is positive, it means that as one variable increases, the other variable increases, or as one variable decreases, the other one decreases. So in both cases, you're going to get a line that basically kind of tilts upward, because no matter if they're both going down or both going up, you're still going to have kind of that positive slope to your graph if you mapped your variables. If you have a negative correlation, that means as one value goes up, the other one goes down. So it's going to look like kind of a negative slope to your graph if you were to graph that relation. And I know that what I'm saying now is kind of abstract, so let's give an example. Something that might have a positive correlation, let's talk about weight and height. As you become taller, are you likely to become heavier? Yes. I mean, obviously, it's not going to be a perfect one-to-one correlation, but obviously as somebody grows, they tend to also weigh more, right? So in that case, we would say those two variables are positively correlated because as weight increases, height also increases, or vice versa. As height increases, your weight also increases. So you would see the slope of your graph kind of going upwards in that case. An example of a negative correlation, those are a little harder to think of. I like to give the example of running. As you age, so say if you get up into your 60s, 70s, 80s, do you think you're going to be able to run as far or as fast as you would when you were 15, 20 years old? I mean, maybe in some weird outliers, yes, you will if you became a marathoner at the age of 60, but in most cases, as people age, the amount of physical activity they're able to engage in kind of decreases, right? So then you would see the age increasing, and then the amount of physical activity or the amount that they could run decreasing. So in that case, you would see a negative slope to your graph. And I'll show you a visual representation of these in a minute. So that's the first major characteristic of a correlation. The second is the magnitude. Magnitude refers to the strength of the correlation. So it's great to know how they're related, if they're related positively or negatively, but we also need to know how strong that relationship is. So how closely the change in one variable is linked to the change in another. So for something like weight and height, you would expect it to be a pretty strong correlation. I mean, obviously there are people who are far underweight or far overweight for their height, but the average person, as you increase your height, your weight is probably going to increase at a fairly stable rate. So in that case, you might have a strong correlation, whereas in other circumstances, maybe, one that kind of comes to mind is maybe the amount of education and your income, because, there are a lot of jobs out there that pay a lot of money you don't need a high level of education for, and there are a lot of jobs that pay a lot of money that you do. So maybe in that case, the correlation will probably still be there. As you have more education, you tend to earn more money, but it might not be as strong. It might be a bit more variable. So if we look at these examples here, and I probably shouldn't have used that as an example because that's listed as the first example here for positive correlation. You can see we've got on the first graph income in thousands of dollars, and then on the bottom we've got years of education. So if you look, as the years of education increase, we see that the income tends to increase. And I guess that was a fairly good example because you can see even though there is that positive slope to the graph, we do still see that the dots on that scatter plot, if we point at all our little kind of dots, they are fairly variable. They're not all directly on that line. Another example, this one is for a negative correlation, is your irritability and the amount of hours that you slept. So obviously, the more somebody sleeps, the less irritable they're likely to be, right? If you have 4 hours of sleep, 3 hours of sleep, you're probably going to be pretty cranky. Whereas the more sleep you get, that might help with your level of irritability or crankiness. So you see the irritability is going up on the side, the amount of hours are going up on the bottom. So in that case, you would see that negative slope, that downward slope to the graph. And then if you look at something like hours of sleep and years of education, personally, I would say that the more education you have, you probably get less sleep because you got way more to do, especially while you're in school. But I think they're more talking about in general over the course of your lifetime. So you see your hours of sleep here. As they increase, do your years of education increase? Well, not really. It's not really kind of a big relationship there. So when we see all the dots are everywhere on the graph, and you'd see that your line, if you're plotting a line of best fit to go in between all those dots, it's pretty well straight. That would mean that there's very small correlation, or close to zero correlation. So the magnitude and direction of correlation is given by the correlation coefficient. So basically, we give a number, which is the mathematical measure used to represent the correlation. Correlation coefficients range from -1 to +1. So you can think of them as percentages. So if you had a -1, that means that those variables are pretty much 100% related to each other. As one increases, say if we were talking about weight and height, which it's not, but if it was, as you increase 1 centimeter, you increase half a pound every single time. If that were the case, then that would be a perfect correlation, so 100% correlation. So a perfect negative correlation would be -1. So that would mean as one thing goes up, the other goes down by exactly the same amount every time. The opposite end of that would be +1, which would be a perfect positive correlation. And again, basically 100% relationship. As one goes up, the other goes up by the exact same amount every time. Do you think that's likely to happen in real life very often? Probably not. right? So we very rarely, if ever, see a perfect correlation. So if we see a correlation of something like positive 0.8 or negative 0.8, they would be considered strong. Those are both, it's important to note, they're both the equal strength. They're equal in magnitude, just in different directions. So even though one is negative and one is positive, and people love to think that negatives are less than positive, that's not what it means in this case. That sign just shows you direction. So positive 0.8 means that as one increases, the other increases by a similar amount. So it's fairly strong correlation, and it's kind of, they're both increasing or both decreasing. Whereas the negative 0.8, they're still the exact same strength of the relationship. They're still very closely related, but as one goes up, the other goes down. And then if you saw a coefficient of 0 or close to 0, that would mean that the two variables are uncorrelated. So the closer it gets to 0, that's the closer it basically gets to kind of 0% related. There's not really much relationship there. So on that graph that we just looked at, if you look at the bottom one where it's kind of the straight line across, those would be pretty much a correlation coefficient of 0 or very close to. Some important things to watch out for when we're discussing correlation are illusory correlations. So those are correlations that exist only in the mind. And a lot of people are probably going to argue with me for this one because it's guaranteed every semester I talk about it, someone brings up the point that they feel that this is true. But a lot of people tend to think that if there's a full moon, that hospital emergency room visits, crime rates, and things like that go up. You'll see pictures on Facebook about teachers, being wary of a full moon because their kids are misbehaving in class and things like that. But in reality, there has been no correlation found between a full moon and higher injury rates and higher crime rates and things like that. So whether or not you agree with me on that one, because I know it is a very commonly held belief, there has been no empirical evidence that it exists. So it's an illusory correlation because it's something that a lot of people have heard of and kind of expect to be true. It's almost pseudoscience in a way, but in reality that correlation simply doesn't exist. Another example is opposites attract. So yes, it's okay to have some differing interests and things like that, but in general, people who are more similar to each other tend to get along a little better, especially when it comes to those major categories such as things like religion and political views and things like that. So these illusory correlations, they exist only in the mind. And another thing to really watch out for is the third variable problem. I'm going to say this right now. You'll probably hear me say it at least 5 more times before the end of the semester. Correlation does not equal causation. Just because two variables are related, even if they have a very strong relationship, even if it was a perfect correlation, that does not mean one causes the other. And it's very, very common to kind of think, well, they're so related, one must be causing the other, but there's always the possibility that there's a third variable that's affecting both of those things. So for example, say we talk about not sleeping well and having trouble concentrating, right? So if you have somebody who's having a really hard time sleeping and you have, they're also having a really hard time concentrating during the day, have kind of like brain fog going on, you might think, well, that brain fog, that lack of concentration, there's a really strong relationship there. It must be caused by the lack of sleep. It's a pretty, kind of simple conclusion that people would probably come to. But in fact, if that person suffers from depression, it's likely that the depression is causing both the lack of sleep and the inability to concentrate. So it doesn't necessarily mean that one causes the other just because they're related to each other. It could be that third variable, in this case depression, that's actually causing both of them. Or the relationship could be the opposite way. Maybe somebody is having a hard time sleeping because they have trouble concentrating. That one's not as great of an example, but you never really know the direction of the relationship, whether one's causing the other or whether a third variable is causing both. So we have to really keep that in mind when we're talking about correlational research. It's great, it shows us if there's a relation there, but it does not help us determine cause and effect relationships. The only research that can do that, as I mentioned back at the beginning, is the experimental research. So experimental research is the only type of research that can actually allow us to establish, to the best of our ability, a cause and effect relationship. So experimental designs improve on descriptive and correlational methods because they are the only designs that can provide us with that strong evidence for causality, that one thing is causing the other. A critical element of experiments is random assignment. So basically, in any experimental context, we really want to have two or more groups, and we want to assign participants to those groups randomly. So basically, each participant has an equally likely chance to be placed in either condition. It allows us to assume that the overall characteristics of people in those two groups are roughly equal. If we do not use random assignment, we run the risk of our results being influenced by a confounding variable. So maybe there's a variable outside of the researcher's control that might affect or provide alternative explanation for the results. And the example that I like to give for this one, this is something that I made up a few years ago and I use it constantly in my classes. Say if you want to test the effect that caffeine has on level of alertness, right? So I'm going to get people to come in. I'm going to divide them into two groups. One group is going to drink, a really strong cup of coffee. The other group, I'm going to still give them coffee because I don't want to have that placebo effect come into play and they're only thinking they're more alert because of the coffee. So I'm going to give the other group coffee, but it's going to be decaf. So I'm manipulating whether or not they're actually drinking caffeine. And I want to see if the group that drank the caffeine is going to score higher on some test of alertness, maybe a reaction time measure. So if I'm conducting my research at, say, 8 a.m. in the morning, and I have 40 participants showing up, and the first 20 that show up, I say, okay, you guys are going to be in the coffee condition, the caffeine condition. And then I take the next 20 who show up, and they're going to be the ones who are in my control condition, so they don't get the caffeine. Can you think of anything that might affect my results there? The first thing that comes to mind for me is that if I'm conducting an experiment early morning, and I take the ones that show up first and put them in the group with caffeine, if I then see that they have much higher levels of alertness than the others, what if that's because the first 20 people who showed up are morning people? Maybe that's why they were up so early and they were the first to show up in the morning. So maybe they generally have a higher level of alertness anyway. Therefore, even though at the end I try to conclude, they had higher alertness, therefore the caffeine must have made them more alert, I don't know if there's actually another third variable that might be influencing the results, such as they're morning people and they're more alert in the morning anyway. So what I should do in that situation is wait until all 40 people show up and then go 1, 2, 1, 2, 1, 2, or something like that, and randomly assign them into two groups. Because in that way, it allows us to assume that, the people who are morning people, the people who are not morning people, all get distributed equally between the two groups. And so therefore, we're trying to eliminate those third variables or confounding variables that might be influencing our results. So again, like I just mentioned, if we do not use random assignment, we run the risk of our results being influenced by a confounding variable, which is a variable outside of the researcher control that might be affecting those results. Random assignment allows us to assume that any observed differences between the two groups are due to the variable that we're manipulating. So hopefully, if we have assigned them as randomly as possible, and we still see that the ones in the caffeine group are showing higher levels of alertness, then we can reasonably conclude that that was based on the caffeine and not just based on any other confounding variable. So here's a little kind of figure that describes some of the major elements of an experiment. So I was just talking about the experimental condition, which would be the group that does receive the manipulation, versus the control condition, which is the group that is exposed to a placebo or some neutral material. So there's a little example here if you want to read through it. For the sake of time, I'm not really going to get into it, but we're going to move on and talk a bit more about some of the other elements of experimental research. So in each experiment, we study two types of variables. We have our independent variable, which is the aspect of the situation which we are manipulating or varying. So in the example I just gave you of caffeine level and alertness, what is it that I as a researcher am manipulating? Is it the level of alertness or is it the level of caffeine consumption? The one that I'm responsible for as the researcher will be the caffeine consumption. Therefore, the amount of caffeine consumed will be our independent variable in this research. The dependent variable, on the other hand, is the behavior that the researcher is trying to predict. So again, going back to that example, well, I'm trying to see if the caffeine affects their level of alertness. I'm trying to predict level of alertness based on the amount of caffeine consumed. So the dependent is the one that we're recording during the experiment and comparing across the groups. So I'd take the people who are in the caffeine condition, and I would take the people who are in the non-caffeine condition, and I would compare them on that dependent variable of alertness to see whether or not the level of caffeine, that independent variable, affected the level of alertness. So in order to keep the difference between the IV and the DV straight, so we're calling independent variable IV and dependent variable DV, think the dependent variable depends on the manipulation of the independent variable. So we are hoping to find that your level of alertness depends on the amount of caffeine you consumed. Therefore, the level of alertness is dependent, and the level of caffeine is your independent. Most variables can be either dependent or independent, depending on which the researcher hopes to examine. So I give this silly example of, maybe eating a lot of chocolate might cause anxiety, right? And in that case, if I want to know whether eating chocolate causes anxiety, then the eating chocolate is the independent, that's the thing I'm manipulating, and I want to see if the anxiety level depends on the amount of chocolate consumed, so the amount of chocolate consumed would be my dependent variable. But maybe the opposite of that is true. Maybe people who are more anxious tend to eat more chocolate. So maybe the anxiety is actually what's causing the chocolate consumption. So if I wanted to look at it from that perspective, then I could say the level of anxiety is the independent variable, and I want to see if the amount of chocolate consumed depends on the amount of anxiety somebody has. So in that case, you can kind of see how a variable can be independent or dependent depending on the situation that the researcher is examining. So it's not necessarily that one variable is always going to be either independent or dependent. It really depends on the relationship that the researcher is hoping to see. Now we're going to talk a bit about the groups used in the research. So I've kind of gotten ahead of myself. Like I said, I really enjoy this stuff, so I give lots of examples and I get really into detail with it. But basically what we've been talking about so far is what we call a between subjects design. So if you have different groups and you're comparing the performance of the participants in each of the groups, that is called a between subjects design. These groups are going to fall into one of two categories. It's important to note, up until now, I've kind of been saying, one experimental, one control group, but you can have multiple experimental groups. So an experimental group is the one that is receiving the treatment. So in our example with caffeine and alertness, the experimental group is going to be given the caffeinated coffee, whereas the control group is the group that does not receive the treatment or stimulus, and they serve as the baseline for comparison. So they help us eliminate the chance of that placebo effect, because maybe just the act of drinking coffee is enough to convince the participant that they're more alert. So maybe people who are just drinking that beverage and thinking that, hey, this is going to help my alertness, they will all show a slight increase in alertness. But how would we know that if we don't have anything to compare to, if we don't have that baseline for comparison? So by taking the control group and not giving them caffeine, and taking the experimental and giving them caffeine, then we're able to compare one group to the other to see if there's a significant difference in alertness between the two. So this, again, is a between subjects design because we have two different groups, and we're comparing them to each other. And so when I mentioned having multiple experimental groups, so maybe you have your control group, which has no caffeine. Maybe you want to see if the more caffeine they have, the more alert they feel. So maybe you have one experimental group that you give, say, 50 milligrams of caffeine to, and another that you give 200 to. So maybe you want to see, as the caffeine increases, does the alertness continue to increase? Maybe at a certain point you've had too much caffeine and then you can't concentrate at all. So in certain situations you might have multiple experimental groups. But in order for it to be considered a between subjects design, you're going to have at least one experimental and one control group. Other experiments involve a within subjects design. So that's basically comparing the performance of the same participants across multiple experimental conditions. So again, and I'm sorry I keep going on with these examples because it's just easiest, but I've got my caffeine and alertness, so maybe I get the group of people to come in on a Monday morning, and I give them decaf coffee, and I get them to do this measure of alertness. Then I get them to come back on Wednesday morning, and I give them caffeinated coffee, and then I get them to do the same test again. So in that case, I'm comparing the same subjects to themselves rather than the subjects to another group of subjects. There are benefits to within subjects designs. Obviously, they're a bit easier to do. You only have to recruit one group rather than two separate groups. You use the participants twice, but there may be problems with, perhaps because they've done the test once before, they're going to do better on it the second time just because they've already been tested on it. So you can see how there could be some disadvantages to using within subjects designs as well. But it is nice to use people as their own control group because you know that there are no differences in them other than the manipulation that you've given to them. So there are kind of pros and cons to each of these types of designs. And I mentioned how random assignment is very important in terms of putting people into your groups. So obviously you don't want to just take the first 20, put them in one group, and the next 20, put them in another group, because there could be some confounding variable that's affecting your selection of groups in that case. But unfortunately, random assignment is not always possible. So for example, a lot of researchers like to examine the differences between males and females. Can you randomly assign someone to be a male or a female? No, right? You have to go with the group that they were given, the group that they belong to. So unfortunately, in that case, random assignment is not possible. So we would consider the study quasi-experimental. So a true experiment has random assignment into the two groups. If you are examining an independent variable that cannot be manipulated, so males versus females, something like that, we would have to consider the experiment quasi-experimental rather than a true experiment. And so that basically concludes our talking about the different types of research methods. So just to kind of finish off this lecture, we're going to talk a bit about how it all comes together. So as we observed in this chapter, each type of research has benefits, but they also have limitations as well. Therefore, we typically use multiple designs, measures, and samples to test a particular theory. It's not good enough to just do some observational research and then say, yeah, I found this result, it's great, it's perfect. I really trust it. Typically, we are going to use different types of designs, different samples, different measurement tools, and we call that converging operation. So we take all the different lines of evidence, our observation studies, our correlational studies, our experiments, and kind of converge them all together, bring them all together, which allows us to be much more confident in the accuracy of our results. So the very last thing I'm going to show you in this section is Table 2.1. It's got an excellent review of the strengths and limitations of each of the research designs that we've covered so far. So here it is. You can see they talk about case studies, naturalistic observations, surveys, questionnaires, correlational studies, and experiments. So the first three here are your descriptive methods that we talked about. Then you've got correlations, experiments, and it gives you at least one strength and limitation for each. So like I said, it's really important for you to know the definitions of the research, the different research designs, but I also would really like for you to be able to give me at least one pro and con of each different type of research. That's really what I'm hoping for you to come away from this with. So that is it for Module 2. That's our research designs. We're not going to get into any more kind of in-depth than that. This is probably going to be the longest lecture for Chapter 2. We're at 19 slides right now. The fourth module is a little longer perhaps, slide-wise, but half of the slides are actually diagrams because it's a little kind of primer on statistical methods. So we'll finish here for today. We're still within the 50 minutes for the class. This will be your lecture for what I believe is Friday the 18th of September. And then for Monday's class, which I'll probably go ahead and record right now, we are going to talk a little bit about ethics in research, how we make sure what we're doing in terms of our research methods are moral and they're not putting our participants at harm, things like that. And then the fourth module, which will be for, I guess, the following Wednesday, we'll talk a bit about statistics and kind of how we then analyze the data that we use or that we obtain from our research methods. So that's it for this class, and I will see you in the next video.